Suppose we want to test market a product. We have this product that's designed for college students. So we gather a sample of college students and we show them a picture of the product along with a description, and we tell them that the suggested retail price is $30. We then ask them to respond on a scale of 1 to 7 how likely they would be to buy this product if it were available, where 1 means that they're very unlikely to buy and 7 means that they're very likely to buy. Now we have in front of us the data from this sample of students, so we know how the sample of students feel about the product. What we don't know is how all college students feel about the product, and that information is impossible to get because it would require sitting every single college student down in a room and having them read this description and indicate whether or not they would buy the product. So since we can't survey every single college student, instead we'll use this sample to conduct a hypothesis test about the population of all college students. The center point on this scale is a 4, meaning that this student is uncertain whether or not he would buy this product. So let's establish a null hypothesis that the population mean response from all students is 4. The alternative hypothesis will be that the population mean response of all students is greater than 4. With our null and alternative hypotheses, we can now look at the data. In our sample of data, the average response was 4.58. The standard deviation was 1.68, and we had a total of 40 observations. Dividing the standard deviation by the square root of the number of observations gives me the standard error of the sample mean, or 0.266. We can now use these ingredients to conduct a hypothesis test. We begin by looking at the distribution of all possible sample means we might get from samples of 40 students. We're assuming that the center point of this distribution is 4. That's our null hypothesis. What we actually observed was a mean of 4.58. To find the p-value, we look at the area under the distribution from what we observed toward the alternative side of the distribution, in this case to the right. That area is 1.8%. So in English, we would say something like, assuming that the population of all college students would rate this product at an average of 4, there's a 1.8% chance that we should have drawn a sample of 40 students that would have shown an average of 4.58 or more. So is this evidence for rejecting or not rejecting the null hypothesis? All p-values range between 0 and 1. P-values between 0 and 0.01 indicate very strong evidence for rejecting the null hypothesis in favor of the alternative hypothesis. P-values between 0.01 and 0.05 indicate strong evidence for rejecting the null hypothesis in favor of the alternative hypothesis. And then finally, p-values between 0.05 and 0.10 indicate weak evidence for rejecting the null hypothesis in favor of the alternative. In our case, we have a p-value of 0.018, which means that our sample of 40 students exhibited strong evidence in favor of rejecting the null hypothesis that the population mean is 4, in favor of the alternative hypothesis that the population mean is actually larger than 4. To calculate the p-value, we start by calculating the test statistic. The test statistic is the observed mean, or 4.58, minus the hypothesized mean of 4, divided by the standard error of the sample mean of 0.266, or 2.18. In Excel, we use the t.dist function. The first argument is the test statistic of 2.18. The second argument is the degrees of freedom, which is the number of observations in our sample minus 1, or 39, true. The t.dist function gives me the area under the distribution from the left up to the value we observe, or 98.2%. My alternative hypothesis is that the population mean is greater than 4, which means I'm concerned about the area from what I observed to the right. That's 100% minus 98.2%, or 1.8%.